Welcome, everyone. We're doing a unique podcast today, and I haven't named this if it's going to be series. I just wanted to uh, get in a Zoom with the smartest engineers I know and sort of get their lens on a lot of what AI first means, etc. So, thank you, Thanos, for being the first and taking out the time for this.
Oh, I thought you
Um,
were going to invite someone else who's going to be the smartest engineer that you know. You mean that's
no,
me?
man,
Oh boy.
we'll grow the group, starting with you. So, high bar. Um, And so the way I've done this, I've just shared this with Thanos, but I spoke to the smartest engineers I know, and I got their questions, put them in one place, and I think I fall in the consumer level of AI users, and I'll just try and define that what it means for me. Um, and so yeah, I got ChatGPT to organize them in thematically. It's eight questions, eight fun questions that I have, and we'll try and get this done in 40 minutes. Uh, Thanos, for those who don't know you, you want to give a quick introduction?
Sure. So my name is Thanos Diacakis. I'm a software engineer by training. I've been at this for about 30 years now, coming up to 30, if not 30. I've been coding since I was a little kid. And once I graduated college, I've since I graduated college, I've done a bunch of different software engineering type gigs, from really small startups to really big companies like Uber and anything in between, and pretty much anywhere in the software stack. And one of the things that I realized in the past 3 to 4 years is that all software teams going to suffer from the same ailments. And they're all really smart people and they know their stuff really well, but they struggle getting software out the door. So I've been focusing over the last 2 or 3 years of taking the stuff that I would do with one employer of helping a team grow and get software out the door, of doing that with an array of clients. So I act as a software effectiveness coach, and I help teams get all the systems and structures and process and culture and architecture in place to be able to get software out the door. So that's kind of
Okay,
me in a nutshell.
great software out the door. That's how people should remember you. That's the brand.
Virtual door
Um, virtual door, and
in production.
hopefully with a lot of people, right? Okay, so the first question. Let's get warmed up. Um, This is a long question. I'll explain it. So the question is, how do you define AI usage versus truly being AI first? And let me explain that. So I read somewhere that there's a spectrum, right? So there are consumers, and consumers say 90% of the people who say, oh, we're using AI, but generally they're throwing the first prompt and picking the first answer that your favorite LLM gives. And they say, oh, I'm an AI user. I think I mostly fall in that category or the next one, which is interactive. So they don't like the answer, they'll refine it, they'll play around it with a few times, and then whatever we have, we'll use that. And then there are producers who are like, I don't know, according to what I'd read, consumers is 90%, interactors is 9%, producers are people who are building systems powered by AI. And so what is AI at the highest level about? Is it about helping people do tasks faster, doing the work for them, or are we fundamentally redesigning how we operate? Um, we're we're trying to define what AI first really is, and I feel like that keeps evolving. So I'll pause and
Yeah,
let.
I'm glad you asked this question because we can, and you have seven more because we can just take the whole 40 minutes on this one.
No,
Uh,
no, we're gonna time you. You have 5 minutes for this.
okay, so let's start pulling this apart. So I think you've done a good job of defining kind of like a spectrum here. And the one thing that I'll say that is interesting, where I can add something to what you said, is that this isn't fixed by any stretch of the imagination. This is changing week on week right now. The tools that are coming up, the capabilities that are coming up are just changing so quickly that where the spectrum is and what the end of the spectrum is just changing. Like the beginning of the spectrum is probably going to stay there, right? You have like your chat, you go type in something and it comes back with something and you're done. But the level of sophistication that we're getting at the other end is crazy cool and crazy insane. I truly can say I haven't had this much fun with software engineering in my life. And I said that like a month ago, and then this last month, it's like, wow, this has changed again, and this is even more fun than it was before. And so let's play near the end of the spectrum because I think that's where the most fun to be had, right? Um, a year ago, we had maybe an agent that we didn't really trust that much because it would delete the production database. So we would give it some prompt, we would get some code back, we would read all the code because we didn't really trust it and it was bad 20% of the time. We wouldn't let it run commands on our environment because at least the sane of us wouldn't let it run commands on environment because it would do crazy stuff and just delete your computer. And then so you'd sit over that and it would be like a bit better than the autocomplete because it could do like a file at a time, but oftentimes that file would be 1,000 lines. It'd be like, no, 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 like break this down, go smaller, right? And we said, the agents, yeah, that's going to be a while till that happens. And then fast forward 6 months, and now you can have a fairly competent agent that you can say, hey, write me this feature, and it will mostly go and write you this feature and come back with code that you'll make a few corrections to. You might steer it architecturally and say, yeah, okay, like redo it this way. But I think that's where the fun begins to highlight because now instead of saying, how do I wire this API with that API? And like, does this exactly mesh with that? And what are the parameters in this function? I can now think more strategically and say, hey, the way you've structured this set of APIs or this set of function calls doesn't make sense, and it'd be more maintainable if you did this. So now I'm not like doing coding, but I'm doing actual engineering. I'm thinking about the bigger picture things. And then fast forward a few weeks later and come to the present. And my state of the art right now is where I have multiple projects running at the same time. I have teams of agents working on each project. I'm really thinking high level of how do I maintain the same level of quality across all these projects. There is really no more time to review code one line at a time. You can forget about that, but you're thinking more strategically of how can I set, what are important things to me for this code base? So for example, I have one client that is building a HIPAA compliant, an app that needs to be HIPAA compliant, right? So there it is super important that we don't leak information across different organizations that are like code tenants in the same app. So now you're thinking in terms of, okay, how do I set the agents to go and check this and recheck this and write the tests and can I make the tests in a way that they're observable and how can I make sure the agents didn't miss anything? So you're moving your thinking to higher level validation and verification of systems and the automation is just happening and the level of abstraction is just shifting higher and higher. That is like super exciting because now we're going instead of like being
And
the
when you
people that
say
are
when you're thinking this is just you managing an entire department of engineering, or is it like a small team of humans? Like I think the way you zoned in on like the end this other end of the spectrum, what is AI first today? It's state of the art for you. Um is there some number like one engineer is equal to five? Is it, like how are we even describing or coming to one page on this?
look, so I could say in the past, if I was hand coding a major feature, medium to major, it might take me like a week to build something and maybe another week to get it deployed and fixed. I can do 5 or 10 of these a day solo.
So when you say in the past, that is before LLMs.
Yeah, before LLMs. No, with LLMs, like, about a month or two ago, I would sit with an agent. I can maybe build one major feature a day because you could sit with the agent, you can just crank through it and do it. Now I can basically have figured out enough of how to do the prompts. It's not like I don't like the word prompt engineering, but you figure out what the agents are good at and you figure out what they're bad at, and you just tell them the things that they're bad at of how to do them. And they're getting pretty good at following instructions. They're not perfect, but they can, if I ship like 8 features to a army of robots for one project, 6 or 7 of them will come back fully working, and I'll need to make very minor changes, if any, and then one will need a bit of refactoring and working.
What's the
So
bottleneck now? What's your
tokens,
bottleneck? Why do you?
machine speed. The bottleneck becomes your ability to consume this information, right? So we were thinking
Hmm.
before you might have like a product manager and they might work with 6 or 7 engineers in a team. And if each of these engineers produced a feature a week or a feature every few days, there was enough bandwidth to consume that. Now there isn't enough bandwidth to consume that, right? If I have to look at that feature, kind of do some acceptance testing, like does this work like it's supposed to? Did it do what I thought it was going to do? Does it work exactly how I'd wanted it to work? Or now that I'm seeing it, I want to do something different. I become the bottleneck in figuring these things out. So that's where my current thinking is going is okay, well, how do we fix that, right? And now you're looking
It's
at starting
dangerously
to
getting
use.
close to the virtual door that you mentioned. Like that's going to become the bottleneck. The software is
Yeah,
good.
people are just jamming their
The,
shoulders through the
the
door, and you.
doorkeeper is like the problem. Nope.
Yeah. But also it's super nice because you can use the AI tools. Like we can use the AI tools to do things like automatic testing and things of that nature. But let me just give you another example, right? I had a just bring this back to this heap app we were talking about. There is a bunch of validations that you need to do to make sure HIPAA compliant. But or I can send the robot to do it. So I send the robot off and say, hey, go check this out and tell me what's happening here. Now, again, this is important. So I'm not going to trust the robot completely. So I'm going to go in and kind of like look at it by hand as well and make sure it didn't miss anything, because the fines of HIPAA are really extensive. But just the first pass of this, it generates, okay, here's your HIPAA compliance plan, and gives you like 50 items. So then I say, okay, now go build all those. So it sends 50 agents, goes build those 50 items, and it comes back and it's built them. And I'm looking at this and how am I going to validate that all these things work? So I again send the robot and saying, for each of these items that you built, go build me a summary, what you built, how you built it, and then tell me how to validate each of these things. And it comes back and it does that. So then now I can go and work through my list of 50 items and a lot faster. Now, obviously, again, I went back and read the HIPAA regulations and made sure that nothing was missing, and actually nothing was missing. And I'm sort of familiar with this from before times as well. So it's not that you can completely let them run loose. There are certain things that are important you can validate, but like if I'm having it building a front end web page, do I go look at the code of something that is like pretty much self-contained? No, I check that it works as a user would do the testing, and then it's out the door. So it's really fun. It's changing a lot, and I think we're gonna really have to refigure out how we're doing engineering. Like, what is this matching? Like, how does the product loop? I think of this, by the way, as two loops. Like, there's the inner engineering loop, where you give it sort of a spec and out comes like a feature, and there's the outer product loop, which is you have a product fit hypothesis, you generate a spec, you send it to engineering, you see it, it comes back, you might tweak it, and you might go a few times until you achieve the fit that you wanted with your feature. Now, these loops could kind of get squished together and merged because does it make sense to build a paper prototype anymore? Because you can send the agent to build you a prototype as a product person. Now, again, you probably don't want to ship it because the way an engineer would prompt it and the way you'd prompt it may be a bit different. You might want to look at how you're not going to die of complexity eventually. Um,
How are workflows and team structures actually changing? Let me explain that. What does a high performing AI native team look like today? And I guess, yeah, today compared to before LLMs, and probably, I like the way how you said 6 months back it was this. I wonder what it is now. Like, how do roles, responsibilities, and ownership shift? Um, what is possible today? Can you become, I don't know, a 3,000 person engineering department or some crazy number? Is that possible by like 5 people now? Because you do have to, as you said, you're the bottleneck, right? Um, and I sort of struggle. It's like what level of agents will report to Thanos, and then how are they coordinating? And yeah, like if you were making Uber again today or something like with some example, what are we looking at?
I struggle with extremely large teams. I think as a species, we quite haven't figured out how to organize ourselves in really, really large groups.
Okay,
Um,
so let's go to the
it's
other
it's
end. Like,
it's it's
what's
tough,
the
but
smallest team
wait,
we
because
can really influence? Okay,
there's
sorry, you were
interesting
going
things
somewhere.
here. Um, I find this question tickles me because like if I this is like it enters in all sort of spheres of conversation, like in the political debate, saying, "Oh, government, which is like one of the biggest organizations that humans have created, is really inefficient. Like we should privatize things." And have you worked at a really big company and seen how efficient those guys are? They're not. Because I think that's the fundamental problem is humans aren't really that great in organizing large numbers. Now, the techniques that we have to organize ourselves in large numbers is some kind of like specializations, and you can look at things like team topologies and how people organize themselves in teams that can move forward, and that's generally trying to bring the numbers to smaller numbers. And there's hierarchies, right, where you can create kind of like some kind of top-down thing and organize yourself. And hierarchies tend to get rigid over time and not really work. So My solution is sort of start small and kind of grow it and try to keep the complexity under control. Now, that's kind of a vague answer that I don't think completely and fully scales, but I think we're better able to answer this at the small level right now than seeing, how does AI completely change a company that has like 5,000 people already? Because now if you were to fully adopt it and you had those teams where you had, 1 PM to 12 engineers and the engineers sort of fully adopt this, you're going to start hitting some very interesting bottlenecks. There is, by the way, sort of an enlightened adoption, right? We've talked about was the human typing the code ever the bottleneck? And in a big team, the answer is probably not. There's probably sort of other bottlenecks in the system that were causing this. But at the same time, code was an expensive part of doing the job, right? So that's why we did sort of paper prototypes, or we used Figma and do things there so we can see them and feel them before we send to engineering. That is no longer necessarily the case. So we can do things differently and things again get squished together. Did I capture the answer of question two in sufficient distinction from
So
question
in
number one for what you're looking for?
in your mind, what is a high performing AI native team size now? Regardless
I
of like the organizational model, hierarchy, holacracy, the teal teams, agile, etc. Um,
I think you'd have a
what
very high performing team with like two or three people.
that's it. Because so for example, let me we're doing bad on time again, but we had front end engineers, back end engineers, architect, the QA people. Now you're saying it's two, three people. And amongst them, how would you divide the response? So who's looking? You still have one person looking for product,
So the
looking
the,
around
the way
product.
that so I'll give you one team that I have right now that I'm doing it this way. Um, I don't do front end, back end architect. That is out the window. Like you better be able to do all of these things, otherwise you're not going to survive in the AI environment.
Mm.
By the way, this was always the case, but when the front end guy has to talk to the back end guy, you just created a bottleneck of massive proportions. Front end is not rocket science, so go figure it out and be able to do both. And that's how I've been hiring for recent memory. And also, you better be able to do your own architecture, right? Because the coding part is gone. So your role now is figuring out, from this spec that you got from perhaps someone else, how does this get translated to reality? That will involve figuring out what does the user want, how are you going to structure this, what does the architecture need, and then you're going to hand off to an agent and it's going to code it. So it's basically one person that will do everything. And where people struggle is I see engineers that struggle. They build you something, and then I look at it and go like, well, come on, dude. Like, the human is not going to want to interact with it this way. So you need to clean it up and make it kind of work that way. And I think that's where engineers will need to grow because they will need to bleed into the product management side now and be a bit more empathetic as to what the user needs are. And so I would have, the engineer is now a self-contained thing that can take feature ideas or projects and be able to then break those down and deal with them and get them out the door and iterate through multiples of these at the same time. And I said three engineers because I think if you're relying on a sort of traditional structure where you have someone that is the product owner of this, I think when you're starting to get a lot more past three, there is a lot of work to be done right now, right? So I have one team where I have three engineers and they're all churning pretty fast and I can barely keep track of them. If I had four, I would not be able to keep track of them. And each of these engineers is now in the realm of building like 5 features a day. That is a lot of code. That is a lot of complexity. That is a lot of functionality. Like we can build seriously sizable products with that amount of team. So that's kind of, this is this week. Ask me again next week. We'll see what that
I
looks
will, I
like.
will, I will. I'm
But
going to move
that's
you to
kind
the
of
next
where that's kind of
question,
where I'm at.
which I think also identifies another bottleneck, right? So this is around engineering quality in the AI code base and sort of like three statements, like AI generated code often introduces more complexity and stylistic variance. How does that impact the review process? Um, and then the other parts, I'll share them with you in this. Have standards around tech debt, code review, and architecture become stricter, or are they more flexible now? And who owns the quality now? Are we there where perhaps an agent can own quality to a certain bar, or is that still, as you said, there's no more time to review each line? So as of this week, um, with the code review process, yeah.
Yeah, let's start by who owns it. You own it. You're the human. The buck stops with you. Now, you're not going to do it. The agent is going to do it, but you own it because if at the same time, if it fails, you can't fire the agent or complain at the agent or sue the agent or whatever. So you own it. Now, let's talk about some of these things that you mentioned, right? So it's like let's talk about stylistic variance. I think stylistic variance was dead like 10 years ago. And I'm not sure why we're even talking about stylistic variance.
Okay.
There's
Yeah.
this thing called linters, and you write you run your linters, and everyone is normalized to the same level of stylistic variance. And I explicitly pick languages like Go that don't have that many ways of doing the same thing, right? So, and you can run Go format, and it just cleans up your code, and we're not no longer fighting about, what is the artful way of writing this line of code. I've kind of had engineers in the past that would fight over this stuff, and it'd be like, you know what, we're not even going to argue about this. This is not about what is the most literally beautiful line of arranged characters. This has a purpose, so we're going to just forget about this. Uh, Taking the humorous aspect of this a little bit away, I think there's a bit stuff that goes a bit out of stylistic variance. Um, and there is kind of like patterns, right? So we have architectural patterns that we follow. So oftentimes what I will have is I will use a language that is simple like Go, and I will use something like a hexagonal or ports and adapters type architecture that has a fairly prescribed way of doing things. And then you can tell the agents in your skills file, this is how we do it. And it's fairly easy to inspect code as just eyeballing it. Like that file looks out of place. What the hell is this file doing here? Or these areas of code shouldn't be touching these areas of code. And you can make a linter that checks for that. So I think there's a lot of things through good architecture and good upfront design, and we can talk about legacy code bases later, you can remove from this. So agents are really good with patterns. So if you start with nice clean code bases, you establish what the patterns are, you can review them kind of like at the eyeball level, but you can also have a pre-periodic process that says, hey, I'm using ports and adapters architecture for this project. Hey, go review it, and it will, go off in the background and do it, and tell me if we veered from this, if you see anything that's off of this, and give it the 5 or 10 things that you see as warning flags for this architecture, and the agent will do it. So that got exciting. You don't have to do the actual, you have to supervise the actual work, make sure the actual work is done, and know what the patterns that you're looking for are. You can also ask the agent, hey, what do you think are the places you could violate this kind of architecture, and give me some ideas. But you have to own it. So I think that complexity is very manageable. And again, that's the fun part of being an engineer, right? That's what I really would like to do, is being able to bubble up a level and be more strategic about my project and my code base and how I structure it, rather than, wiring A to B. So I think this, again, moves the level of abstraction, but is a much more helpful way of doing things that produces speed and quality that go hand in hand. Um,
Just extending this, so and I'm the non-engineer, right? I've gone towards the dark side of business. Um, the question extends, like, are you building evals into CI/CD, or do we still rely on human validation at
yes and
scale? At
yes.
scale,
I think
okay.
that's kind of very project dependent, right? There's some projects that are the output is non-deterministic because they're kind of AI first, and you ask questions of an agent, it sends it off to an LLM. So you have to kind of build eval that is um, a stochastic process at some point that figures out, is this thing working to the level of quality that we require. Not all projects require this, and I'm beginning to see projects where there are in CI/CD, you're beginning to put qualitative AI things, right? So, I mean, you have agents like, companies like CodeRabbit do this, where they go and do your pull request reviews, right? And if they don't pass, the human has to look at it again. Actually, I'm not sure even why we're doing this, because they actually will give you the prompts that will go fix what they suggest. And now you have plugins that go back, shifting left onto your desktop that will, once you've written it, it will just fix it automatically. So by the time it hits it, it isn't there. But, sometimes these things don't run. Sometimes the agents don't listen and don't run these validation checks. So the buck stops at CI/CD for me. So you could definitely add things. And I'm seeing teams do this, where you do have prompts in CI/CD saying, okay, my architecture is like, so check this pull request and make sure that these things have been done, and just stop here, flag it if it's not.
Okay, okay. So now shifting gears, and I seem to recall you feel strongly about this topic, but I think the door is going to come back. How do you measure productivity gains from AI? What metrics do you trust?
I,
And how do those gains translate into pricing?
you'll know it when you see it. So productivity metrics is a notoriously fraught area in software engineering, and it's really tough to measure. I think there are a lot of metrics that we have that we can use that give you good data, but as you start extending them and relying on them, it's possible. I'm not worried about gaming the metrics as much as kind of having the wrong kind of um, incentives. So for example, if you measuring like I like the flow framework for metrics, which is divides work in four categories: features, bugs, defects, and features, bugs, investments, and risk. And then you can basically look at the output of teams of all these items, and you can clearly see like gains when you start using AI that these items now go up. So that's kind of what I usually reach to. The usual caveats for that is now you start comparing engineers and saying, hey, Bob over here did like 8 of these, but Alice did 2, so we should promote Bob and not Alice. And you get in trouble with that because maybe Alice was working on something that was way more complicated. So again, now if everyone is doing 100 and Alice is doing 1, you might want to go and look into why Alice is doing that. But again, these are kind of nuanced things. I should need to be careful about how we do this because then it
Does
can
it ever
just
get
start.
simpler? There's
No,
the
it
iteration.
doesn't, and it now will get simpler. But I don't think that's the reason. I think a lot of people see just chuck the metrics out the door because they can be perverted. And my answer is no. Just use the metrics reasonably and don't pervert them and don't do stupid stuff. So don't fire Alice because she had one PR because that was like a major refactoring. And be supportive of people rather than using the metrics to fight them. Again, this is easy to done in a small team. It's tough to scale, and companies that try to do this at scale are a bit more problematic. I like Dora metrics as well, but I think these are a bit sort of more low level. They're fun and interesting to go look at and do some diagnostics of what is happening here, what is happening there, especially across bigger orgs. But I think I find the flow metrics to be more kind of measuring what matters at the end of the day because it's like shipping of features out the door, and I like when things go out the door. So I kind of usually will reach for that. But joking aside, you will know it when you see it because your company structure and your internal functioning is going to be so much different when you're doing it right. Especially like post like the last couple of months, right? Because maybe before then, if you're using the agents, you're going like a little bit faster, but like all the cracks are not we're not showing yet. If you had any cracks in your system, they're showing now.
Okay. And are you seeing this translate into price now? I guess positively or negatively?
The price,
Um,
how do you mean price?
Pricing of, I guess, the work to be done. Uh, and as it I guess for a product company, it would be end output, but for in terms of as a consultant or as services, um, do you see this impacting pricing? Like you can get more done with AI now.
You can definitely get more with AI now. I don't have much visibility on how that is impacting software engineering services being sold.
So what
Um,
about you yourself, right? So as a fractional CTO, um, are you seeing people perhaps not very maturely push back and say, oh, we should be able to do this with a smaller team and perhaps at a lower sticker price? Or is the price of something getting done for you really tied to that output and outcome? Um,
yeah, so I guess it's a little bit of both. I think a few projects that I've started recently, what you see is before you might have needed to hire like 3, 4, 5 people to get it done, whereas now you may not need that many. You may need one or two. So I don't see much um the individual people pricing if you're selling, humans by the hour, that sort of thing is not that crazily different right now. But the customers that I'm working with may be like, do we need to hire that many? And the answer is usually no. You can start with like one or two, see how you're doing, and then you can add more
Team
as you learn how to
size,
scale.
team size is
Yeah.
taking. And so like
That said, a lot of customers really want to get out the door and find product market fit and ship quickly. So, and I'm
Hmm.
seeing they're not like if you can show that like if you add more heads, you can actually generate things a lot faster, that they're not averse to doing that, but usually that is not necessary because in the very beginning of a project, you're still figuring out the right direction. So like, massively parallelizing a bunch of stuff when you're not sure of where you're steering
Is this
towards.
true just for startups or for large company projects too, where I guess with AI, they're looking for validation first?
I haven't had visibility in the really large companies yet. And I think like a lot of the really big companies have depending on how they're adopting AI, they might have sort of more restrictive policies where they're not able to fully make use of like all the newest sort of bits and pieces, right? You may have security policies in place and says, no, you can only use like these models or these tools. And so the engineers are not using the really most cutting edge stuff. And therefore the needs for humans to, babysit less capable agents is still there. But I think that's going to change like that as these tools mature, that is going to change. And I think you can do more with less. So there may be a shifting there, but I think it's also a fallacy to say that, the software engineering industry is going to like shrink a lot because I think usually when the cost of something goes down, the demand goes up. It's like if software became cheap to write, now we can build more software because it covers more of our needs. I do my expense reporting on a spreadsheet and it's just annoying and painful. So I just sent an agent overnight and said, for my expense reporting thing, build me an reporting application for my, one person company. Off it goes and it does it, right? So these are things we weren't able to do before. I think we may see like this company sort of pulling back and staffing teams with smaller projects. But once this is figured out, I think we're going to see a big boom again.
Have you seen now moving towards risk, trust, client concerns, any pushback around IP, data privacy, leakages, prompts, and I guess what guardrails do you feel are essential right now in rail deployment?
Yeah, I think we covered that under quality. I think there are tools and techniques we can use to do that. I think the IP stuff has mostly died away. Like I haven't heard anyone thinking like, oh, is the code generated by the agents going to be an
Mhm.
IP problem for me for like over a year? But I think the quality problem is definitely something that we know that we have to address. And I think we talked around question three or so about like the different techniques that we use there. Again,
Okay.
I see bigger companies. Some of my clients that are in bigger companies are much more conservative with how they approach this, and I think that is somewhat reasonable. Like they have a lot more to lose if they mess something up. But I think they also have to sort of drive that fine line that if they go too slow, then the smaller companies are going to go and eat their lunch because they're able to innovate a lot faster with much fewer resources than they are. The smaller companies have much less to lose, right? If you're going out there as a startup, you can go a lot faster. And
Hmm.
again, I'm not saying like YOLO this. There are security standards and all the good engineering that we should be doing, we should still be doing, but you now have the tools to do it better and faster. So don't ignore it, just do it better and faster. I'm not of the opinion of just go vibe code everything, don't ever look at the code base, and just ship it right out the door. That is not responsible. You'd not do
Fair
that in
enough.
any other
I feel that's
profession.
a very balanced, good way to think about this. So the last two themes, I'm gonna skip one, which was around, hey, what are the two, three real use cases? Because or I'll let you pick. So I'm personally interested in your thoughts on how to evolve a company being AI first. And we had this discussion, and you mentioned like outcomes where, and I think towards the start of this also, iterations, quality, complexity, planning. And then you said, okay, there's the input side, tech, process, culture, and you feel like improvements come from identifying the weakest dimension and then leveraging the right lever and not just blanketly pushing best practices. Um, I was hoping you could share a little bit more about your
Yeah, so
thinking
so maybe
about
let
it.
me sketch this model out a little bit. I think you
Okay.
covered it quite well, but for someone that hasn't heard this before, um, my working model for software engineering is that there are three things that I control as inputs in a team, right? There is the process, which is a short-term lever, which says, okay, before you can merge this PR, you got to tick these three boxes, or every morning we do this, or that's our Scrum process or whatever. There is culture, which is how process sort of evolves in the long term, right? Like people see what other people do, and if you're a bigger team, you can set process all you want, you can set strategy all you want, but culture will eat all those for breakfast because people sort of get used to doing something in a way. And I think culture is a different lever. You can't just mandate culture. You have to sort of create it by demonstrating the right things. So process culture and then technology. And this can be like architecture and systems and a bunch of ways that you implement things. These are the three levers that I generally control when I go into an existing team. Now, to make these changes, I think of the process of delivering software as kind of like having four sort of it's not phases of maturity, but there's kind of four um, capabilities that you got to have. And the first one is iterations, like the ability to go from an idea that I want to build this feature to having this feature in production in any way, shape, or form. So can I like write the code, compile the code, test the code, and like push a button and go to production? And can I do that in a relatively short period of time? Like not a week, a day. Like if you were a week and you're doing it in a day, great. If you're in a day and you're doing it in an hour, even better. But can you do that? And at this phase, I don't care much for quality because I can't control quality unless I can ship stuff to production. If you have a bug, but you can't make any changes to production, I can't fix the bug. So the first thing that I look at when I look at a team is do you have this ability of doing iterations? And again, you'd think that by now most teams are like doing DevOps and CI/CD and all that good stuff, and most are, but a lot of people, especially when you start veering outside our little bubble of Silicon Valley, they're not. And you see some archaic systems of you need to press like 8 buttons to do releases, and you press the button and deploy the client, but you forgot to deploy the server, and now everything's broken. So we usually go and look at our levers and see what we can fix to get iterations out the door. Once we have that, very quickly now you got to deal with quality, right? Because I just press, if I want to push crap out the door, that doesn't really help me. So then we look at again the usual stuff of automated testing and CI/CD, and now in the agentic world, we're looking at how we're going to do this with agents and do it faster, higher, stronger, and making sure that what we're shipping out is not bad and meets the user needs. Again, we covered a lot of that, so I won't duplicate it here, but if you now have iterations and quality, now you're in a pretty good spot where you can start shipping stuff at a good clip. And what usually happens with this phase is that teams get really good at that and start beginning to build complexity. And when I say complexity, this is not just complexity like the code gets complicated, but it could be you have too many features and they interact with each other. You have too many teams and they interact with each other, or you have too many layers in your structure of your teams and interact with each other. So it's complexity can be multidimensional, and complexity starts biting you in the rear really, really quickly. So I start looking at mechanisms to keep that complexity apart. If you're looking at the microcode level, we talk about loose coupling and tight cohesion, right? These are tricks that we have to manage complexity. There's a lot of these tricks up and down the stack. So we look at these things. And finally, once we have iterations, quality, and complexity under check, now we're beginning to get able to get planning and predictability. And that's kind of like usually companies think about this backwards. And when they have problems, they try to like really plan really tightly in advance. They'd have no ability to execute, but they try to plan really well. So they go build a year's plan, and that falls apart in the first week. And then next year they build another year's plan, and that's just a complete waste of resources. So I usually tell my clients that we're going to have a lot of work to do to get to the planning and predictability phase. We're not going to reach for that first. We will get incremental improvements all the way there. But at some point in time, we should be able to get into some cadence where we're able to say, we can look at a month and say, this is what we're going to do and be able to hit it. And we can look out 3 months and be able to hit it. Look at a year and be able to hit it. Usually, no, that's like too far for most like really innovative software projects to be able to figure that out. But you can have some high level planning for that. And again, you can look across your tech process culture and figure out how do we structure that to get better planning predictability. So across these things, like when you look with a team, I will usually go from left to right and figure these things out. But sometimes you kind of jump around a little bit. If you're always doing it backwards, you're doing something wrong. But there's some kind of like sense of the plan, and you're trying to figure out the bottlenecks, right? Where is the bottleneck? What is the one thing that is really slowing down my output? And it can be anywhere across these four places. The solution can be anywhere across your three levers that you have to pull, and you fix a bottleneck, and then the bottleneck moves around, and you fix another one, it moves around, and that's kind of the gig.
This makes a lot of sense for me, even outside of engineering, like leveraging OKRs. It's always like the planning part. Whatever tool you use, it becomes like such heavy lifting in its own right that you're not moving otherwise, and then it's like, why are we even planning? This is Let's just
Yeah,
figure
I mean,
this
if
out
you think
and get
about it,
it
like,
finished.
people tend to compare software to building a house, and it's not really the same because if you're building a house, like if you take a bathroom, right? There's only so many ways you can build a bathroom. You're not going to do the tiles first and then do the rough plumbing. There's always going to be like a certain ordering of things. Now, you have one or two sinks, you may have a tiled shower or a bathtub or whatever, but the degrees of freedom you have with building something like a house is just pretty cookie cutter. Whereas software, like literally the rules of physics could be changing under your feet, that we have infinite degrees of freedom of how we build software. So it's really hard to predict in advance. And that's why I really don't like going in and, predicting how this is going to work. Because we've been doing this for long enough that we've never been able to predict anything for like a year out. So why do we keep telling clients that we can do this? We cannot. We can give certain parameters. We can structure the project to manage risks in a certain way. We can give rapid feedback cycles. So we make sure we're hitting the market in the right ways. But our ability to predict these really new projects, right? Because if software that wanted to do what we need to existed, we'd go buy it, right? We're building it because it's completely new. No one has ever really built this before. Most software projects are completely bespoke. Now, there are some that are like cookie cutter, go write a plugin for this, and we've done this 1,000 times. But most stuff that most of our audience is listening to is usually not like that.
Anas, thank you so much. We've gone a little 4 minutes over, but I think mostly on time. Thank you so much. Lots of insights here. And I think we could have gone for an hour, especially on this last question. I
This is a
had
lot of fun. I can
definitely.
talk for a week about this stuff.
Be careful what you wish for. I can be back. Yeah, I feel like this last one, like in terms of getting into actual case studies or use cases where what did you add to the process to improve the quality of, I don't know, teams, outputs, etc. That would be fun to get into. So I'll bug you about that, but
Let's
I'll
do it.
stop. Well, thank you so much for today, and we will do it. I will be back. We'll do a part two of this then.
Awesome. This was a lot of fun. Let's do this again.
Thank you so much, man. Have a great day.
Thanks, man.
Bye bye.